Nearly 75% of the Earth is covered by water. Water is one of the most abundant natural resources available to us. One good thing about water is that it is a renewable resource. It keeps moving in a hydrological cycle, changing from one form to another, but it is never lost or spent. Water is essential for life. Besides drinking, water is essential for many of our daily requirements, like cooking, cleaning, and washing. Water is vital for cultivation. This is the reason why all early human settlements were made along rivers or other sources of water. Water is also essential for industries and economic growth. Hydropower is one of the most important sources of electricity in the world. Industries also require lots of water for production, cleaning, and disposing waste. We all know that 75% of the Earth's surface consists of water. You must be wondering that when water is such an abundant resource, why is there a scarcity of water in different parts of the world? The answer lies in the sources of water available to us. Around 97% of the total water available on the Earth lies in the seas and oceans. This water is saline and not fit for human and industrial use. Only 2.5% of the total water on the Earth exists as fresh water that we can use. Nearly 70% of this fresh water is locked in the polar ice caps and glaciers in Antarctica, Greenland, and mountainous regions of the world. Just under 30% lies buried in the earth as groundwater. A small fraction of it is above the ground or in the air as water vapor. Only around 0.3% of the total fresh water exists in rivers, lakes, and ponds. Which are the main sources of water for human and industrial use. Thus, we see that only a tiny fraction of the total water available on the Earth occurs in a form fit for human and industrial consumption. Precipitation or rainfall is another source of fresh water. India receives around 4% of the total rainfall in the world. Rainwater can be an important source of fresh water. However, in the absence of proper conservation measures, most of it flows back into the sea through rivers or is lost through evaporation and pollution. India has substantial water resources. Still, a study by UNESCO places India at the 133rd position in the world in terms of water availability per person per year. Water scarcity is posing an alarming threat in most parts of the world, including India. What is water scarcity? The unavailability of sufficient clean water to meet personal, domestic, and industrial requirements in an area is called water scarcity. We usually associate the problem of water scarcity with dry, hot regions like deserts that receive scanty rainfall and have very few sources of clean surface water. Here is a map that shows projected water scarcity in the world by the year 2025. As you can see, water scarcity is set to become a serious problem in the whole of India. Not all regions that face water scarcity have poor water resources. What leads to water scarcity in regions that have abundant water resources? An increase in demand, unequal access to water, overexploitation, and contamination of existing water resources are the main factors that lead to water scarcity in regions with abundant water resources. Let us study these factors in detail. This brings us to the question: what are the main causes of water scarcity? India has the second highest population in the world, which is still increasing fast. An increase in population means a greater demand for fresh water for personal and domestic use. To feed the increasing population, more and more land is brought under cultivation. This also increases the demand for water for irrigation purposes. Since independence, India has seen a major industrial revolution. Rapid industrialization exerts greater demand on water resources. Since industries use a huge quantity of water for production and cleaning. Over 70% of India's population still lives in villages. However, people living in cities have better access to water than people living in most villages. This unequal access to water resources also leads to water scarcity. Groundwater is an important freshwater resource. However, in order to increase their produce, most farmers today use private tube wells to irrigate their fields. This overexploitation of underground water is leading to falling water table and water scarcity. Similarly, the use of bore wells by modern housing societies to provide water to their residents is also overexploitation of underground water resources. Freshwater sources like rivers and lakes are often treated as dumping grounds for domestic and industrial waste. This pollutes the fresh water and makes it unfit for our use. Such contamination of fresh water also contributes to water scarcity. The use of chemical fertilizers and pesticides in modern agriculture leads to pollution of fresh surface water and groundwater. Fresh water is a limited resource and essential for our health and well-being, for growing crops to ensure our food security, and running our industries for economic growth. Thus, there is a pressing need to conserve and manage our water resources. Dams are used to control flooding in flood-prone areas by regulating the flow of water downstream. One such example is the 𝙎𝙃𝙊𝙃 Dam in the Mahanadi Basin in Orissa. Dams can also be used to divert water into existing smaller streams to promote inland navigation. This provides an alternate way of transport, reducing congestion on roads. Several dams are at scenic locations and have become popular tourist attractions and recreation spots. Dams are called multi-purpose river projects due to the many ways that they offer to manage our water resources. When multi-purpose river projects have so many benefits to offer, why do we hear protests against construction of large dams in India? A dam creates an enormous reservoir of water that submerges vast stretches of the surrounding area. This leads to the destruction of natural vegetation and soil. The submerging of farmlands and residential areas leads to mass displacement of people. These people give up their land and resources for the nation's greater good, but are usually never compensated enough. Dams are used to control flooding in flood-prone areas by regulating the flow of water downstream. One such example is the 𝙎𝙃𝙊𝙃 Dam in the Mahanadi Basin in Orissa. Dams can also be used to divert water into existing smaller streams to promote inland navigation. This provides an alternate way of transport, reducing congestion on roads. Several dams are at scenic locations and have become popular tourist attractions and recreation spots. Dams are called multi-purpose river projects due to the many ways that they offer to manage our water resources. When multi-purpose river projects have so many benefits to offer, why do we hear protests against construction of large dams in India? A dam creates an enormous reservoir of water that submerges vast stretches of the surrounding area. This leads to the destruction of natural vegetation and soil. The submerging of farmlands and residential areas leads to mass displacement of people. These people give up their land and resources for the nation's greater good, but are usually never compensated enough. Major benefits of large multi-purpose projects go to big landowners and industrialists, while the local, poor, landless people have little to gain. This widens the social division between the rich and the poor. Better irrigation facilities attract farmers to grow more water-intensive commercial crops. This is leading to over-irrigation and increase in soil salinity. There are ecological problems as well that can be caused by the construction of dams. Take the example of the carp fish. The carp fish is one of the many species of fish that swims hundreds of miles upstream to return to the waters where it can breed. Dams block the migration of these fish, upsetting the ecological balance and putting several aquatic species in danger. There are several examples of sudden release of large quantities of water from dams, resulting in large-scale flooding in plain areas. These are man-made disasters that not only destroy life and property, but also lead to extensive soil erosion. Most Indian rivers flow across several states. Large dams obstruct the free flow of river water, resulting in disputes between different states over water sharing, and also over the sharing of costs and benefits of the project. For example, two states in India, Andhra Pradesh and Karnataka, which receive water from the Krishna and Godavari rivers, objected when the government of Maharashtra tried to divert more water from these two rivers for a multi-purpose project at Koyna. The diversion of water would indeed reduce the amount of downstream flow to Andhra Pradesh and Karnataka. This will adversely affect agriculture and industry in those states. Environmentalists associate large dams with causing of earthquakes, spread of waterborne diseases, and degradation of soil. Constructing a large dam is expensive and has lasting effects on the surrounding areas. Most of the multipurpose river projects in India so far have not met their designed objectives. Rivers, lakes, ponds, and wells are our main sources of fresh water. But what is the main source of water that feeds our rivers, lakes, ponds, and wells? The answer is rains. Rainwater feeds the sources of our rivers. Rainwater also seeps into the ground to recharge our underground water resources. Rainwater is one of the purest forms of water available in nature. However, rainwater is available to us only for a few months in a year. The process of collecting rainwater during the wet season to meet our fresh water requirements in the dry season is called rainwater harvesting. Rainwater harvesting is practiced in India since ancient times. Many ingenious techniques were developed based on local weather conditions and soil types. Let us explore. What are the different methods of rainwater harvesting practiced in India? In Himachal Pradesh and Jammu, in the western Himalayas, rainwater and water from glaciers is harvested using diversion channels called culls or gulls. These culls can be several kilometers long and run along steep mountain slopes. Water flowing through the culls is collected in reservoir tanks in the villages. Water from these tanks is used for irrigation as and when required. Farmers in Bengal traditionally used inundation channels cut through river embankments at times of floods to irrigate their fields. The flood water that flowed into the fields also carried silt, a natural fertilizer. In some areas of Rajasthan, especially in Jaisalmer, earthen embankments called 𝙁𝙇 are built around farms to collect rainwater during the rainy season. This saturates the soil for cultivation. In the semi-arid regions of Rajasthan, earthen check dams called 𝙤𝙈𝙋𝙊𝙁 are used to collect rainwater flowing down slopes. This water is allowed to percolate into the ground, rising the level of groundwater. A lot of rainwater falls off the roofs of our houses. Don't you think all this water can be used if we can only collect all the raindrops? This is, indeed, done in a good number of houses. One of the most widely used methods of collecting rainwater is rooftop rainwater harvesting. This method is used in many parts of India. In a rooftop rainwater harvesting system, PVC pipes are used to collect rainwater falling on the roof. The water is filtered through sand and bricks and stored in tanks for immediate use. Excess water is diverted to wells where it collects and recharges groundwater. In many parts of Rajasthan, rainwater collected through rooftop harvesting is collected in large underground reservoirs called tankers. The rainwater collected in such tankers is shielded from sunlight and thus remains pure for a long time. People use it as drinking water. With the construction of the Indira Gandhi Canal, water is readily available round the year in western Rajasthan. Thus, the practice of rooftop rainwater harvesting is slowly being abandoned. However, some people still practice it. Around 200 households in Gendatoor, a small village in Mysore, Karnataka, have also adopted rooftop rainwater harvesting. At 80% collection efficiency, each household can collect 50,000 litres of rainwater every year for its use. You would think water harvesting is carried out only in areas where water scarcity is common due to scanty rainfall. However, this is not true. For example, Shillong in Meghalaya is close to Cherrapunji and Mawsynram, the wettest places on earth, and still faces water scarcity. Now, almost all households in Shillong use rooftop rainwater harvesting to meet almost 20% of their total requirement of water. Another interesting rainwater harvesting technique used in Meghalaya for centuries is bamboo drip irrigation. Bamboos are split to make shallow channels. A complex network of such bamboo channels is used to divert and carry water from rain-fed springs to the farms. Channel sections in the farm allow the water to drip near the roots of the plants.